So the first thing we need to do is to tell Studio X, and indeed the software in the flybarless unit, which way the flybarless unit is mounted on the helicopter. You can see that there are a number of options as to how the flybarless unit is mounted, and in fact on this occasion our flybarless unit is mounted in the default orientation, which is with the flybarless unit horizontally and with the pins on the flybarless unit pointing to the rear. Okay, so that's this screen complete, so let's go to the next screen. Before we do that though, perhaps I should point out that whilst you're working on the Studio X software, every time you make a change it's saved automatically to the flybarless unit. Now whether it's saved on that page or whether it's saved when you complete the page, I'm not really sure. But when we click the next tab to go to the next page, then certainly our changes here will be saved. It's probably worth a read of the notes on the top of the page, and obviously what they're telling you is that you need to set the update rate as high as possible because that will get a better response from your flybarless unit. However, don't think you can automatically set the highest that's available because your servo may not be capable of operating at that update rate, and as a result of that you're going to damage your servo and you've got an expensive repair on your hands. So the first question is, what servos do we have? Well, on this heli the servos are the standard Align DS530s for the swash plate. So there are two possible sources where we can derive the servo update frequency. It may be listed in the manual, but if not, you can see there's a link in the software to BeastX's servo list. And if we have a look, they've got a list of servos from different manufacturers, and for each of those servos they tell you both the swash plate frequency and the pulse length. Interesting to know, if you take the DS415M as an example, the frequency, if the servo is used as a swash plate servo, is 200 Hz. However, if you're using that same servo as a rudder servo, then the frequency you need to select is different. Obviously the pulse width remains the same whatever. So we're using DS530s, and for a DS530 the swash plate frequency is 200 Hz and the pulse width is 1520. So back to Studio X, it's just a matter of setting the appropriate update rate. There's a couple of ways you can do that. You can pre-select the frequency by selecting one of the buttons at the bottom, depending on what your servo frequency is. And if it's not in that list there, then you can just use the plus and minus buttons to set the frequency that you're looking for. In our case it's 200 Hz, so we'll select that. So having completed the swash plate servo update rate, let's move on to the next page. Although I think that the Studio X software is generally very good, I do have a bit of an issue with it. And what has actually happened is we started off looking at swash settings, and then we've jumped to rudder settings, and then we continue setting the rudder up and then jump back to the swash. There are other menu items which are similar as well, and they do seem to jump around in a bit of a haphazard way. But as I mentioned previously, if you work through the pages sequentially, then you'll make sure that every step is done, even though the order doesn't always appear to be immediately logical. Rudder servo center pulse width. our DS535 has a pulse width of 1520 microseconds, and as you can see that is the default selection in the BStex software, so no changes to be made here. So let's click the next button and move on to the next page. Rudder servo update rate. So we need to set the servo update rate for the rudder servo, and once again we can click on the BStex servo list to find out what is the appropriate setting. And once again, looking at the BStex servo list for the Align DS535, we can see that the rudder servo has a pulse length of 1520 and the rudder update frequency is 270 Hertz. So we know our servo has a rudder servo update rate of 270 Hertz. If we look at the buttons at the bottom of the page, the closest we can get is 200 or 333 Hertz. So just select whichever one you fancy, it doesn't really matter, because what we're then going to do is use the plus or minus buttons to give us exactly the update frequency we're looking for, which in this case is 270 Hertz. Once that's selected, then this page is complete, so we can click the next button and go on to the next page. Rudder servo and gyro adjustment. So this is where we get into the nitty-gritty of setting up the rudder on the heli. There's 4 steps which are clearly labelled there, but before we can go into those we've got to complete the steps that are not so obvious in the text at the top of the screen. The first thing obviously we have to do is connect the rudder servo to channel 4 on the flight wireless unit. We then attach a servo horn to the servo and make sure that it's at 90 degrees to the tail linkage rod. We then adjust the tail linkage rod to make sure that it's the correct length, so that it's given a centre position on the tail linkage, or sometimes it's offset slightly to counteract the torque effect of the main rotor head. So going through those steps one at a time, let's first connect the rudder servo to channel 4, and again we connect it in such a way as the white signal wire remains at the top. Again making sure it's push fully home, and again making sure that we don't damage the pins as we're doing so. The second step is to make sure the servo horn is perpendicular to the linkage rod. Now you can see at the moment, if I use this Allen key to point to the servo horn, that it's actually sitting about 45 degrees to the left. So what I need to do is remove the hex bolt from the centre, take the servo horn off the spline and reposition it at 90 degrees or as close as I can get it. So I'll just do that now and then I'll be right back. So you can see I've now removed the servo horn. It's as perpendicular as I can get it to the servo, which will make it perpendicular to the tail linkage rod. I can't get it exactly at the 12 o'clock position, but that's as close as I can get it. If I move it on to the next spline, it moves it further to the right. But that's not an issue, because there is a way of centering that servo horn in the software, which we'll come to later. But at the moment it's important to get it mechanically as close as you can. I've also remembered to apply thread lock to the hex bolt to make sure that it doesn't come undone in flight. I mentioned how we set up the servo horn at 90 degrees and get that as close as possible mechanically, but that's not always possible to do so because of the splines on the servo horn. So you can see in the software at the bottom of the page for the rudder, servo and gyro adjustment that there is a centre position, and there's a plus and minus button, and we can use that to adjust the position of the servo horn. So I'm now going to select a value, and I'm going to go for about 100. I mean, this scale's fairly arbitrary, and it makes really small adjustments to the actual servo horn. So I'll just go for 100 and I'll have a look to see whether that has actually got the servo horn in the position that we require. It's quite difficult to see, but you can see that the servo horn is now perpendicular to the servo and also perpendicular to the tail pushrod. It must be my lucky day, because that 100 adjustment has given me exactly the position I require on the rudder servo horn. The rudder servo horn is now at 90 degrees to the tail linkage rod. It doesn't matter what value you eventually end up with, but I would suggest that you end up with a very large value, and then possibly that's telling you that you might be able to move it round one more spline on the servo and then go back to recentering using the centre position on this page. So just to recap then, the first thing we do is connect the servo to channel 4 on the fly barless unit. The second thing we do is make sure that the servo horn is at 90 degrees. We get that as mechanically close as we can, and if necessary we can use the centering in the software to get it absolutely perfect. Having done that, then it's a matter of adjusting the length of the tail linkage rod so that when it's all connected up, the tail rotor slider just here and bearing holder is in the centre position. Now we know it's in the centre position because if we look at the two tail blades, and it's quite difficult to show on camera, then the two tail blades are exactly over the top of one another when I place them in the same direction. If this tail pitch slider here was not centred, then you would see an offset between the two tail blades. But as they're exactly over the top of one another, we know that this slider is in the centre position, and we know that the tail linkage rod is the correct length. So having completed those 3 steps, we can now go into the software properly and go through steps 1 to 4, making sure that the tail is adjusted correctly so that we've got correct rudder authority when we're flying the heli. So step 1 now tells us to use the reverse function in the transmitter to ensure that when you move the rudder stick to the left, the nose of the heli will go left, and when you move the rudder stick to the right, the nose of the heli will go right. Well, obviously that will only work in the air when the heli is flying, but there's quite a simple way you can make sure it's going to move in the appropriate direction, which I'll show you now. To carry out the rest of the setup, we need to connect the tail blades. As a precaution, before I connect the tail blades, you can see that I've already disconnected the motor wires. You actually only need to disconnect 2, but with those wires disconnected, there's now no danger of us accidentally starting the heli up and the tail blades becoming live. So the simple way to check which way the nose of the helicopter will go when you move the rudder stick is to first of all rotate the tail rotor hub until the tail rotor hub is vertical. Once you've done that, then bend the uppermost blade through 90 degrees so that it's parallel with the boom. Then when you move the rudder stick left and right, the tail blade will point to whichever direction the nose of the heli will turn during flight. However, it is possible when you move the rudder stick to the left that the tail blade actually goes in the opposite sense, and when I move the rudder stick to the right, the tail blade goes left. If this is a scenario you have, then what you need to do is to reverse the rudder settings in your transmitter. So to reverse the rudder function in the DX8, press the roller to access the function list, servo setup, reverse, move down to the rudder servo and click the rudder servo switch once, and you can see it reverses the rudder servo direction. Having done that, back out of it, I'll return to the home screen. Having reversed the settings in the transmitter, when I now move the rudder stick on the transmitter to the left, the tail blade goes left, indicating the helicopter would turn left in flight. When I move the rudder stick to the right, then the tail blade goes right, indicating the nose of the heli would turn right in flight. So that's step 1 completed. So now let's move on to step 2. And in step 2, what we're doing is we are checking that the software is aligned with the stick movement in the transmitter. What we have to do is, in the software, check that the left and right white buttons illuminate when we move the stick in the appropriate direction. So if I now move the stick to the left, you can actually see that the right button is highlighted and the little white dot goes across the screen to the right, which is incorrect. And similarly, if I move the stick to the right, obviously the reverse happens. So at the moment, the software and the transmitter are not aligned correctly. So it's just a matter of, if necessary, clicking the inverted button, and now when I move the stick to the left, you can see that the left button illuminates, and when I move the stick to the right button illuminates. So just to highlight the differences between step 1 and step 2 on this page, on step 1 you're checking that the rudder physically moves in the correct sense, and if necessary reverse it in the transmitter to make sure it's correct. In step 2 you're checking that the software picks up the correct movement of the rudder stick, and if it doesn't, then you reverse it in the software. And it is important that you understand those two differences and that you don't get them mixed up. So in step 3 we are going to adjust the maximum servo throw to make sure that we've got full movement on the tail of the heli without the servo binding. We can do that by adjusting the plus and minus buttons for left and right on the servo throw section until we're happy that we've got full range of movement and, as I say, no binding. What we're checking for is to make sure that this Y yoke here moves all the way to the right towards the tail rotor hub, and similarly that the slider here moves all the way towards the tail case. If there's too much movement on the rudder servo, then what will happen is the tail pitch slider will either touch the tail case or the rotor hub, and it will cause the servo to burn out. And normally you can hear it buzzing as you actually try to deflect the transmitter stick one way or the other. So what I'm going to do now is hold in full left stick, and whilst I'm holding that in, I'm going to increase the values for left servo throw until that Y yoke is almost but not quite touching that rotor hub. And it's a matter of just keep adding a little bit at a time until it's almost there. And I think that's probably about as far as we can get. I need to do the same now for the right side, but this time, although you can't see it on this camera angle, this little black slide shaft here will actually go slightly inside the tail case, but we'll basically run it across until the tail pitch slider, the silver bit, is almost touching the tail case. So now holding on right stick and at the same time increasing the throw in the Studio X until the maximum movement is available without actually binding the servo. And I think that is it there. So now we can move the stick from one side to the other without the servo binding. No danger of burning the servo out, but at the same time we've got maximum deflection possible. Okay, so that's step 3 done. So let's move on to step 4. In step 4, what we're doing is we are providing a datum in the flybarless unit through Studio X, so it knows when you have maximum stick deflection for the rudder. And again, this is one of the issues I have with Studio X. Step 4, what it says and what it means are not quite the same. What it says is increase the stick throws, servo endpoints for rudder in the transmitter until the labels left and right light up when the stick is at maximum positions. Now you only need to move the stick a small amount and those labels left and right will light up. They'll go a sort of teal green colour. But what they're actually looking for is for those labels to go either red or blue, and you keep increasing the endpoint until the label goes one of those colours. So let's go through that process now. So I hold the rudder stick all the way across to the left. And whilst holding the rudder stick all the way across to the left, I go into the function list, servo setup, travel's already selected, go to rudder, click it to select it, and when it's flashing I slowly increase the rudder travel 1 point at a time until the left box on Studio X changes to red, and that is the setting that I'm going to use. So I now hold the rudder stick all the way across to the right. So whilst holding in right rudder all the time, I then slowly increase the travel 1 point at a time until the right box changes to blue. Note that the two values are not the same. One's 104, 105. They may be the same, they may be different, that doesn't matter. Having set the rudder travel correctly, I'm now going to back out of the menu so I don't change it by mistake. So that's step 4 complete. And not only is that step 4 complete, that's the rudder setup complete. So we'll go to the next page, but we will basically look at the swash plate setup in a separate video.